Welcome to this lesson on electrolysis. In this session, we will explore what electrolysis is, how it works, key terms you need to know, and examples of electrolysis in molten and solutions. Electrolysis is the process where an electric current breaks down a compound. This only works for molten ionic compounds or aqueous ionic solutions. Always remember that covalent compounds cannot conduct electricity, and so they do not undergo electrolysis. In the solid state, particles in ionic compounds are locked in fixed positions. There are no free ions, so they cannot conduct electricity. But when molten or dissolved in water, the ions are free to move and electricity can flow. Exam tip: always remember, ionic compounds can only conduct electricity in the aqueous or molten state, not in the solid state. Let's look at some of the key terms used in electrolysis. Firstly is the electrode. An electrode is a rod made of metal or graphite that allows current to enter or leave the electrolyte. You will always find two electrodes in an electrolysis cell. Next is the electrolyte. The electrolyte is the substance being broken down. It must be molten or dissolved to allow ions to move and conduct current. Note: when answering questions, always state that the electrolyte must be either molten or in aqueous solution. The anode is the positive electrode. Anions, which are negative ions, are attracted to it. This is where oxidation happens. The cathode is the negative electrode. Cations, which are positive ions, are attracted to it. This is where reduction happens. Exam tip: remember the rhyme, panic, positive anode, negative is cathode. Now, let's look at how electrolysis works. To carry out electrolysis, three main parts are needed. First, an electrolyte, which is an ionic compound that is either molten or dissolved in water so the ions can move freely. Second, two electrodes, the cathode, which is the negative electrode, and the anode, which is the positive electrode. Finally, a power supply is connected to the electrodes, completing the circuit. Exam tip: do not confuse the cathode and the anode. The cathode attracts positive ions, and the anode attracts negative ions. In electrolysis, ions move depending on their charge. Positive ions, called cations, move towards the negative electrode, the cathode. Negative ions, called anions, move towards the positive electrode, the anode. This opposite movement of ions is what allows the compound to break apart. You can remember this with the phrase, panic, positive is anode, negative is cathode. At the electrodes, chemical reactions take place. At the anode, which is the positive electrode, negative ions arrive. These ions lose electrons, and this process is called oxidation. At the cathode, which is the negative electrode, positive ions arrive. These ions gain electrons, and this process is called reduction. In summary, reduction is gain of electrons, oxidation is loss of electrons. To remember this, use the phrase oil rig. Oil stands for oxidation is loss, while rig stands reduction is gain. Now let us apply this to an example. We will look at the electrolysis of molten lead bromide. When electricity is passed, the lead ions move to the cathode, and the bromide ions move to the anode. Exam tip: always check which ions are present in the electrolyte before predicting the products. Now let us show this in terms of half equations. At the anode, each bromide ion loses one electron. Two bromide ions combine to form a bromine molecule and release two electrons. The half equation is Two bromide ions form bromine gas and 2 electrons. At the cathode, the lead ion with a 2+ charge gains 2 electrons to form a neutral lead atom. The half equation is lead ion plus 2 electrons gives lead metal. Exam tip: always balance the number of electrons in half equations. This is a common area where marks are lost. Let us answer an exam past paper on electrolysis. Molten silver bromide is electrolyzed using electrodes. You are asked to completing the circuit to show the wires and power pack, labeling the anode. Name the product formed at each electrode. And circle the giant covalent molecule which can be used as an electrode. To watch the video on giant covalent molecules like diamond and graphite, kindly click the link on the top right corner. You can pause the video to give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.